So today then, we're going to keep talking about graphing a little bit and talk about rate of change and slope. How many of you remember talking about slope before? Yeah, okay. We're going to take these sections really slow, okay? We're going to just talk about rate of change and slope today, nothing else, and slope formula, okay? So we're going to take these kind of slow. We're going to do a little activity in the middle here today, but this is over rate of change and slope. So given a graph or given some points, can you find the slope between them? Okay, what slope is? It's a ratio. What's another word for like a ratio? What's a ratio look like? What's a ratio? Like a fraction, right? A fraction's a ratio. Like 1 to 3 or 1 divided by 3, that's a ratio, right? So slope is just a fraction or ratio that's the change in the y-coordinates divided by the change in the x-coordinates, always. It shows how steep a line is, okay? How steep it is going up, how steep it is going down, how flat it is, that sort of thing. Yeah?
So wouldn't be its reciprocal?
Not always.
Okay.
Not always, okay? It's always the change in y divided by the change in the x, okay? What the rate of change is it's exactly the same, okay? It's just a synonym for slope. It's a ratio that describes how much one quantity changes with respect to another quantity. So how much y changes with respect to x. Rate of change is just another word for slope, okay? There's just different contexts we use it. Different contexts that we use rate of change in. Okay. The symbol for slope is the variable m. Anytime you see the variable m, we're talking about slope. Okay. Slope is equal to, again, the rise, that's the change in the x's, how much you go up or how much you go down, divided by what we call the run. The run is how much you go left to right. Okay. It's always how much you go up or down, divided by how much you go left to right. Okay. The change in the y-axis goes up and down, the change in the x goes left to right. Okay. The slope formula is this. Okay, we're going to use this a lot today. Now it says m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now what does that mean? Okay, anybody know what these little numbers below the variable are called? I mean, I know that's a 2 and that's a 1, but like the variables, little numbers in the top right we call exponents. Anybody know what these are called? Not powers. Powers we would still consider in the top right. What about these that are in the bottom right? Anybody know what these are called? Not a C. S. Sub. No, good. That's a good guess. It's not okay. These are called subscripts. Okay, subscripts. Subscripts are little letters in the bottom right corners of a variable. They have no mathematical meaning. Like when you have this, that's an exponent. Okay, that's x squared. You take x times itself. Subscripts have no mathematical meaning. The reason we use them is so you can tell the difference between different y variables and between different x variables. So if I had two sets of coordinates, like right here, I call the first set x sub 1, we just call it sub for subscript, and y sub 1. This means the first set of coordinates, the first x coordinate, the first y coordinate. And then this one would be x sub 2, y sub 2. The second set of x coordinate, the second set of y coordinate. Okay? So that's what these subscripts are. Again, no mathematical meaning. It's just, instead of using variables y, z, w, and r, or something like that, we're talking about coordinates here, so we use the variable y. We just call this the second y coordinate, this the first y coordinate. This the second x coordinate, this the first x coordinate. This is called slope formula. Okay? We will use slope formula a lot today. And that's how you find slope, is you take the second y coordinate minus the first, divided by the second x coordinate minus the first. The change in the y's divided by the change in the x's. Or rise over run. Okay, so this is what we're going to be talking about today. We have 4 different types of slope, okay? And we can think of them in terms, if some of you may already know it, but in terms of a roller coaster, okay? How steep something is. 4 different types. The first, okay, and we always want to look at it from left to right. When we're looking at a graph, we want to look from left to right. Is it going uphill, downhill, that sort of thing. We always go from left to right, just like how we read. All right, we read from left to right. We want to look at this from left to right. Okay? And I think this has some sound effects here coming up, if I remember right. Not this one. Okay? Positive slopes go uphill from left to right. So if you have a graph that's going uphill from left to right, the slope should be a positive number. Okay? Always. When it goes uphill, it's positive slope. And we always look in terms from left to right. Okay? That's going uphill. The number we get for the slope would be positive. Okay? Negative slopes go downhill. Okay? So with the slope we get should be a negative number when they go downhill from left to right. And then we have two special cases. Okay, we have what we call the zero fun coaster, which is a flat surface or straight surface. We'll see why it's zero in just a second. And then we have the impossible one that's straight vertical, right? Couldn't go vertical because these people would fall out. Okay? So you have the vertical one and the horizontal one. Now we want to talk about what the slopes between those two things are. Okay? When you have yeah, that's there is a sound effect. Listen, we'll do it one more time just so you can hear it.
Boring.
Yeah, pretty good, right? Okay. So the horizontal roller coaster has a zero slope. It's zero fun, right? Just going across a straight line. That horizontal line has a zero slope. Horizontal line's always zero. Slope is zero. Okay, and then I think we have another sound effect here. I didn't put those in, but I kept them in there. Okay. We have a vertical slope, which is impossible, right? We call that undefined slope. A slope that's not definable. It's not zero. It's not 1. Okay. Undefined means there is no slope for a vertical line. It's impossible to go vertically, right? Another way you can think of it is how you walk, right? If you walk across a flat surface, it requires zero effort, right? So the slope is zero on a flat surface, but you can't walk up a straight wall, right? So a straight wall is impossible, undefined, or not possible. There is no slope of a straight line, okay? So otherwise, you can think of it like this too. Vertical lines, undefined slope. Because from left to right, it's just straight up and down. There's no uphill or downhill. Okay. So those are our 4 cases of slope: positive, negative, zero, or undefined. Okay? Every linear line has one of those 4 slopes. Okay? Positive, negative, zero, and undefined. So let's look at these graphs to determine what they are. Positive, negative, zero, or undefined. The slope of this line would be negative. It's going downhill from left to right. This would be a negative slope. Good. How about this? Positive. It's going from left to right. It's going uphill. Whatever I get for the slope would be positive. Okay. Zero. It's a flat surface. Zero effort. Right? Zero fun. That slope is zero. And then the last one, undefined. Right? Like when you define a variable, you give it a meaning. This is undefined. There's no such thing as a slope for a vertical line. Okay. So the rate of change in slope, again, it's a ratio of the change in the y variable divided by the change in the x variable. Okay? We're going to do this little activity here. I'm going to pass you out a sheet of just graph paper, and you're going to make whatever picture you want with a straight edge and a sheet of graph paper. Okay? I'll give you an example here in a second. I want at least 10 straight lines somewhere on the paper. Okay? And with each of those 10 lines, you're going to go through and label them as positive, negative, zero, or undefined slopes. And then you're going to hang on this paper for a little bit later. We're going to do something else. So for example, let's say I had this. Here's my graph paper. And let's say I used my straight edge and I wanted to make, I don't know, a number. So I did something like this. All right, number 1. Okay. So this has at least 10 straight lines, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This has 11. Okay. I want to go through then and label each of these lines as positive or negative. So like looking at this line, is that a positive slope, negative, zero, undefined?
Positive.
Positive. So I'll go through and just put a positive there. What about this one? Zero. What about this one? Undefined. So I can just label it UND there. What about this one? Zero. What about this one? Undefined, right? It's a vertical line.
But it's moved.
I guess a little bit moved. It's supposed to be. Yeah, I'll try and fix that. Yeah, good point. Yeah. And then I would have slope of 0, undefined, 0, undefined. What about this one? Remember, go from left to right, positive. Okay. What about this one? It would have a negative slope because it's going. So that's what you're going to do. I don't care if you want to put initials, a number, a picture, whatever. You're going to draw a picture with a straight edge, and you're going to go through and just label the lines as either positive, negative, undefined, or 0. Make sense? Okay, so now you have some picture, okay, with a bunch of positive, negative, 0, undefined slopes. And we're going to go through it and show you how to label the actual slopes of them in just a second. Okay. Now, let's briefly talk about rate of change here. Now, rate of change is how much something changes at a constant rate, right? So, if you're ever given a table and it says find the table, use this table to find the rate of change and explain what it means. So I have the X values here are the number of computer games in this case. The Y values here are the costs. So 2 games cost $78. 4 games cost $156. 6 games cost $234. I want to find that rate that these games are going up, right? In this case, it's a constant rate, okay? I want to find what is that rate that it's going up. And again, we do that by using the slope formula, which says the slope is equal to the change in the y's, or the second y coordinate minus the first, divided by the change in the x's. Yeah. And what I can do is I can pick any set of these points to plug into this formula, and I should get the same answer. Just as long as if it's x1, I label the y1 that goes with it. And if it's x2 or x sub 2, I label the x sub 1 that goes with it. For example, if I call this point x sub 1, the first x coordinate, what's the first y coordinate? 78, because it goes with 2, right? So let's call it the first y coordinate. Okay. And if I call this the second x coordinate, that means this is the second y coordinate. And then I'm just going to plug these numbers into this formula to find the rate of change. So it says y sub 2, which I called 156, minus y sub 1, which was 78, divided by x sub 2, which was 4, minus x sub 1, which is 2. Well, simplify this. 156 divided by 78 is 78. 4 divided by 2 is 2. And 78 divided by 2 is 39. So that means the rate of change that these games are going up is 39, or in this case, $39, right? One game would be $39. 2 would be 78. 3 of them would be 78 plus 39. 4 of them would be 156. 5 of them would be 39 more than this. It's going up by a constant rate of 39. Okay. That's the same thing as slope. Okay. I just have the x coordinates were the number of computer games and the y was the total cost. This is called the rate of change. Okay. And again, this slope formula is what we use for that. So one more example here. For example, this table shows the cost of using computer at a cafe for amount of time. So for 2 hours, costs $7. For 4 hours, costs $14. For 6 hours, costs $21. Okay. So I want to figure out what's the rate of change. What's the rate of change, okay, for this example? Pick any x coordinate to be x sub 1. That means this is y sub 1. And let's say I pick this as x sub 2 and y sub 2. Didn't matter if I use this one, I should still get the same thing. Slope formula says you take the second y minus the first and divide that by the second x minus the first. So I called y sub 2 minus y sub 1, 14 minus 7 divided by x sub 2 minus x sub 1, 4 minus 2. 14 minus 7 is 7, 4 minus 2 is 2. I can't simplify this any further without getting a decimal, right? When we talk about slope, don't simplify this, but don't write a decimal. Okay. In this case, we're talking about money, so if you wrote a decimal, that's fine. Okay. But when we're talking about slope, leave this as either an improper fraction or just a reduced fraction. Okay. Don't make it a decimal. You'll see why a little bit later. But if we did make that a decimal, it'd be 3.5, or it'd be $3.50. So for every hour I used it, it cost me $3.50, right? Because 2 hours would be 7, 4 hours would be 14, and so forth. So in this case, the rate of change was 3.5, or 7, or 7 over 2. Okay. Again, we use slope formula to find that. We just picked 2 points and plugged them into our problem. Now, when we're talking about slopes of a line, there's two different ways you could look at it. So you have a bunch of lines on your paper, right? Let's say you wanted to find the slope of this line. Now, first of all, is the number I get going to be positive, negative, 0, or undefined? Positive. It's going to be positive because it's an uphill line, right? It's an uphill slope. Okay. And remember, slope says also that it's the rise, or how much you go up or down, divided by the run, how much you go left and right. So what I'm going to do is I'm going to pick 2 points that are easily visible on this graph. Meaning, like this point right here, I don't know what that is. It's probably like 1.5 and 2.5. See, I don't really know the exact coordinates of that. Somebody give me a point on this line that definitely is on this line. Yeah. 1, 2. Yes, that is definitely on that line there. Okay. Let's label that. That's 0.12. Okay. Somebody give me another point that's definitely on this line. Yes, Eddie. 5, 6. Yes, it is.
3, 4.
Yeah, 5, 6 is on there. It would go through it. Okay. So this is 5, 6. So I want to find the slope of this line, the actual slope. I know it's going to be a positive number. I want to find the slope of this line. One way you can do it is just take how much you went up or down from one point to another, divided by how much you went left or right. So for example, to get from this point to this point, I would have to go up here and over here. How many did I go up? 1, 2, 3, 4. Divided by, because that's how much I rose, how much I ran, or how much I went left or right. 1, 2, 3, 4. And 4 divided by 4 is 1. So the slope of this line is a positive 1. I knew it would be a positive number. Okay. Well, some people ask a good question, well, what if you went from this point to this point? You should get the same thing. Let's see. But now I go down. So when we talk about going down on an XY plane, okay, is it usually a positive or negative number? When you go down, it's negative, right? So to go from here to here, I have to go down 1, 2, 3, 4. So I'm going to make that negative 4. And then to go to the left, I go 1, 2, 3, 4. And that's also negative because when you go to the left on an XY axis, it's negative numbers. So I'm going to take how much I went up or down, divided by how much I went left or right. And what's negative 4 divided by negative 4? Positive 1 because it's negative divided by negative. I get the same thing. See? So it doesn't matter which way you go, you should get the same answer. And I know the number I should get should be positive because it's an uphill slope or uphill line. The third way you could find slope, if you wanted to, is you could use the actual slope formula. y2 minus y1 over x2 minus x1. You could take the second x coordinate or second y coordinate divided by the first y coordinate minus the first y coordinate divided by the second x coordinate minus the first x coordinate. So let's use these 2 points that we picked out here. And I'll label this one x1 and y1, and I'll label this one x2 and y2. Doesn't matter which one was which, I just picked them that way. But so this says take the second y coordinate, which I called 6, minus the first y coordinate, which was 2. 6 minus 2 is 4. Then take the second x coordinate, which was 5, minus the first x coordinate, which was 1. 5 minus 1 is 4. And 4 divided by 4 is 1. So when you're given a graph, if you just want to count how much you go up or down and divide it by how much you go left and right, that would give you the slope. If you want to pick 2 points on the graph and plug them into the slope formula, that would work. Okay. Let's look at 1 or 2 more. This line, is it going to be a positive slope or a negative slope? 0, undefined. It's going to be a negative number. I should get a negative number whatever I do. So let's pick 2 points on the graph. Again, I'm going to pick 2 points that I definitely know this line crosses through. Somebody give me 1 point that this line definitely crosses through. 0, 1. I'm probably not going to pick 0, 1 because it doesn't quite look, it's really close, and I won't give you any that are this. questionable, but 1, 0 definitely does, right? Looks like it does. The point 1, 0. What about another one? Negative 2, what? Yeah, let's go one more than that, I think. Yeah, let's go negative 3, 5. So let's find the slope of this line. Let's do it first by rise over run. Okay? By rise, how much I go up or down, divided by how much I go left or right. Let's go from this point to this point. Doesn't matter, but let's do that. So I need to go up first. How many did I go up? 1, 2, 3, 4, 5. And it's positive, so I went up 5. And then I need to go to the left, and since I go to the left, does that mean positive or negative? Negative. 1, 2, 3, 4. So the slope of this line, I can't simplify anymore, is 5 over negative 4. If you went the other way, let's say you went this way. I went to go from this point to this point. I will go down 1, 2, 3, 4, 5. So that's negative 5 because I went down. And then I go to the right 1, 2, 3, 4. I went to the right, so that's positive. These are the same thing. 5 over negative 4 is divided by the same, or is the same thing as negative 5 divided by 4. One, I just happen to go down 5, then to the right 4, and one, I happen to go up 5 and to the left 4. They're the same thing, okay? Because I end up with the same result. It doesn't matter if you have one negative, if it's with the numerator or the denominator, okay? So the slope of this line is negative 5 over 4. If I wanted to, I could also use slope formula and then just label this like x1, y1, and this x2, y2 if I wanted to, plug it in, I should get negative 5 over 4. And I know I should get a negative number because it's a downhill slope. Kind of see how that works? So, before we do this one, we're going to have you go back to your picture. One case is you get the graph like you have on your paper and like we just did up there, and it says find the slope. So you do how much you go up or down divided by how much you go left or right. That's how you find the slope. The other case is if it just gives you 2 points and no graph. And it says find the slope between these 2 points. Now technically you could go through and plot these 2 points and then count how much you go up or down divided by how much you go left or right. That would take a lot of extra work, right? The easier way is to just use the slope formula between 2 sets of points. Label one set of points, the first x and the first y, like I did up here, and label the other set of points, the second x and the second y. So if we do that and use the slope formula, it says take the second y minus the first, so that's 2 minus negative 3, because that's the first y, divided by the second x minus the first, which was 5. And then I simplify this. Well, what does this double negative become? 1 positive, so 2 plus 3 is 5. And negative 4 minus 5, negative 9. That can no longer be simplified, so that's my slope. So would the line between these two be uphill, downhill, flat, or vertical? It would be negative, so that means downhill. Right, it would be downhill because I get a negative slope. Right. If I plotted these 2 points and drew a line, it would be a downhill line because it's negative. Good. Okay. Let's look at one more here. I want to find the slope between these 2 points. Again, you just have to pick one of them to be the first x and the first y, and the other one to be the second x and the second y. So if I took what the slope formula says, I take the second y minus the first y divided by the second x minus the first x. Double negative here becomes a plus. Negative 2 plus 2, 0. 4 minus 0, 4. Well, what's 0 cut into 4 parts? 0. So the line between these 2 points, is it vertical or is it horizontal? The line between these 2 points, since the slope is 0, is it vertical or horizontal? Remember, it's easy or 0 effort to walk across something horizontal, right? The line between these two would be horizontal. And that makes sense, right? If you went to 0, negative 2, and 4, negative 2, it would be a horizontal line through that point. Okay. We just did one like that. Oh, wait. Okay, let's do this one. Find the slope between these 2 points. So I'll label this as the first x and the first y, second x and the second y. So the slope formula says take the second y minus the first divided by the second x minus the first. Negative 3 minus 4 is negative 7. That becomes a plus. Negative 2 plus 2 is 0. Does anybody have a calculator out in front of them? Yeah, Joel, could you plug in negative 7 divided by 0 and tell me what your calculator says on it?
Divided by 0 error.
Yeah, it says divided by 0 error. Some other calculators might say just error or can't divide by 0 because you can't divide by 0. There's no answer. So what do you think, since I get an error here, what do you think the slope of this probably is? Yeah, this is undefined. Okay, undefined slope. So if you ever get divide by 0, so this is a what type of line then? It's a vertical, okay? It's flat up and down vertical line, right? You can't walk up, it's impossible to walk up a vertical line, but it's 0 effort to walk across the horizontal line. Right? So this would be a vertical line. So if you ever get something divide by 0, that's undefined. Okay. All right, we just did that. You found the slopes on your paper of 5 different lines, okay? And we're going to come back to these probably at the end of class today or next class. So, we're not doing that. We're going to start our quiz 3 and then go over our worksheet on finding slope.